So again, my name is Dr. Jim Lanny. Happy to be here with you. And really, this is about helping you get through your DNP projects. If you're a PhD nurse, that's fine too. Um, but again, I'm interested in where you are in the process and then how it can be supportive to you, me and my team. And on my team is Ashley, who really helps faculty with trials, demonstrations, and courseware, and then Melissa for everything else, including student support as well. So with that being said, let's just go ahead and get going here. So first thing I want to do is ask folks, where are you in your project right now? Just planning your PICO in the data collection process or analyzing your data. And if you want to take a second with that and answer that, that'd be great. Kind of scope where we are here. All right. So about half of you filled it out. I'll give the other half another second to do that. All right. So it's kind of mixed. Most people are just in the PICO planning phase, a little bit over half, and then a quarter are collecting data, a quarter are writing it up. So I'll spend some extra time on that PICO question. And try to boil it down. I call it PICO light, because I think the PICO question is often all encompassing when in fact we kind of want to get to the bones of it, which is what's the study about? Okay. Um, okay. And those collecting data, we'll talk about setting up data and analyzing data. I will show you Intellectus Statistics, which shows you a quick way to analyze your data. So, okay, thanks for those responses. So the agenda today is to kind of talk about PICO and really how do you translate your PICO question into a data analysis plan. Talk about level of measurement. If you know this already, sorry, I'll be brief, but level of measurement is mission critical in determining what statistical test you're using. We'll talk about the language of your question. It's very important if we're talking about prediction or differences or relationships. Okay, so that language kind of really foreshadows what the analysis is going to be. We'll talk about selecting the tests. I'll touch on control charts. We'll talk about setting up. Most folks are doing paired t-tests. Last time I looked in the literature, about 80% of DNPs are doing paired t-tests. And that's been my experience as well. I'm going to talk about the difference between clinical significance and statistical significance. And clinical is really the importance of differences or relationships, where statistical is this traditional p-value, 0.05, and so forth. I will mention that the tool does offer data cleaning. For those that are in the thick of analysis, data cleaning is 90% of the job or more, and that the tool Intellectus Statistics often offers a discussion draft, and then we'll walk through the demo. Okay. Okay, so PICO, who are you studying? What intervention are you doing between this pre-post tests? What are you comparing it to? Typically, it's pre to post tests. The outcome variable is critical, and the time period is included. To me, it's an overwhelming question. Okay, when really when I'm looking at designing like what statistical tests I should use, well, that population is already determined. Okay, the intervention does really not impact the statistical test. Really, we're looking at the outcome variable compared to what, okay? And it could just distill down to, hey, what's the difference between X and Y, or what's the difference between pre and post, okay? So uh, I know that you have to write it as a PICO. If I had my druthers, I would be, what are the variables and what are you doing with them? Comparing them or something of that sort. So at the end of the day, where most people get stuck is in that data analysis plan. And that data analysis plan is, what is the study aim and how are we measuring those variables? And that's what we'll talk about next. So there's three broad classes of measurement of a variable, quantitative variables. The first is nominal. It's Latin for name only. It's just categories, okay? Red block, blue block, green block, okay? There's no hierarchy per se. We're not on the color spectrum here. We're just saying that these are categories: Republican, Democrat, Independent, male, female, non-binary. They're just categories, no hierarchy. They're just names of things, okay? And it's I'll say the lowest form of level of measurement, okay? The next is really ordinal. And ordinal has both the characteristics of a label, like, young, middle-aged, old-aged, okay? Okay, it's got names, but it also has an order to it. The important thing about the ordinal is that traditionally the intervals are not the same, okay? So young could be 5 or younger, school age could be, kindergarten till, 22 when you're in college, and then, out of college or something of that sort. So there's no equal spacing in between those labels. Scale is named several things. It's called continuous level variables, or scale level variables, or interval level variables, or ratio level variables. Basically, they're numbers that have labels 1, 2, 3, 4. It has an order 1, 2, 3, 4, but there's also equal spacing. Okay, so if we're looking at a 1-year-old, a 2-year-old, and a 2-year-old, a 3-year-old, they all have the same spacing of 365 days. And you can do things with that, like take averages of those things or sum those things, okay, and in meaningful. All right, and I've given some examples of age and blood pressure and things of that sort. Okay, so those are the only three you need to know, but mission critical when you go to design that data analysis plan. Okay. Okay. Oftentimes, Likert type items are being used. Okay. Whether it's confidence scales or there's 1,000 scales that use Likert type items. Technically speaking, Likert type items are ordinal in nature. That is to say, hey, is the real distance between someone who's strongly disagree to disagree really the same kind of distance between someone who disagrees versus truly neutral? Okay, so so it is ordinal, and there's conversations about it or controversies about it. But the rule of thumb is this: at the individual item level, if it's a 1 to 4 Likert type scale, I think the correct pronunciation is Likert type, by the way, but people say Likert type. If it's a 3 to 4 point Likert scale, you should treat it as ordinal. If it's a 5 to 7 point Likert scale, you can treat it as continuous without any problem. Okay. When you do treat them as scale, okay, you can do things like get an average or get a sum. Okay. And the types of tests you can use, we're kind of in t-test land and ANOVA land and a regression land. Okay. Okay. So let's see how I did here. So a 10 item burnout scale is averaged into one composite score. Okay. So I have 10 questions about burnout. And the question is that composite score a nominal level variable, an ordinal level variable, or a scale level variable? Let's see how we're going to do here. And I invite everyone. There's a few people here. I think my benchmark is 75% participation. So for those others, go ahead and put your answers in there. Don't be shy. I won't call you out this time. All right. All right. Give it another moment. Last few people. Okay. So we're really kind of all over the map here. Okay. So about a quarter of you said nominal, a quarter said ordinal, and half of you said scale. So once you start averaging or summing these things, we are clearly in scale land. And if you think about when you took a test as a kid, right? And you had a 10 question test, okay? Each question you can get it correct or incorrect. Okay. That's nominal. That's just a label, correct or incorrect. All right. Once I add those, you got 9 out of 10 correct or 8 out of 10 correct, I'm in scale. So once you start averaging or adding, we're completely in scale land. Okay. Um, don't be fooled by, that it may have been a 10-point Likert scale. Okay. Again, averaging or summing, you're in scale. Okay. All right. Thank you for answering those. So let's talk about some statistical language, okay? Um, there's many different buckets here. I'm going to name 3 such buckets. And those are differences in the language, right? Are there differences on A by B? Are there differences on 5K runtime by sex? Are there differences on BMI by age group or something of that sort, okay? Or pre-post tests, okay? Once you're looking at differences, well, I think I get to the next slide is the combining the language and the test. But just know that that's a very common way to ask questions, all right? The next one is relationships, okay? Does this variable relate to that variable? Is there a relationship between staffing ratio and patient falls, for example, okay? And then prediction is the third bucket, and that is we're seeking to see if one or more variables predicts or impacts the outcome variable. By the way, some of the prediction and regression language, they call the independent variables predictors, and they call the outcome variable or the dependent variable the criterion level variable. Okay, so a little bit of language there, um, but if you stick with those kinds of differences, relationships, and prediction, you kind of get there. All right. That's going to really kind of foreshadow some of the analyses that we select. Okay. And as I say here, most DMP projects are looking at this pre-post intervention. Okay. All right. Although all of them can well appear. So now we're going to be mixing the types of questions we have with the levels of measurement. So if you're doing a pre-post test or paired, that is you're matching folks. By the way, if you're doing a pre-post test, you want to make sure you have a common identifier so you can match them. I just did a project this morning. We had the location actually of the latitude and longitude of the post, but not the pre. If you can't match them, we're doing a different kind of test here. So when you're doing these things, try to pair them. Some people say, well, it's totally anonymous. Okay. Put down your mother's birth date and the first letter of your dog. Okay. Some way of matching these things. Okay. So if you're doing a paired test, you're looking pre-post and those levels of measurement of scale, okay, like confidence scale or self-esteem scale or some other knowledge scale at 2 time points, we were in paired t-test land, okay? If you're doing pre-paired, pardon me, pre-post and then paired again, but they're ordinal, okay, truly ordinal, at 2 time points, is the Wilcoxon test. Should also say, if the paired t-test assumption is not met, normality, okay, we're going to be doing a Wilcoxon sign rank test, okay? If we're looking at group differences, okay, any outcome variable is scale, and I have 2 groups like runtime by sex, you can't be in both sexes, you're either in one group or the other. We're going to be doing an independent sample t-test. You'll get a video of this recording, but you can also take a picture of these slides as well as a quick cheat sheet. If your outcome variable is scale, and I'm looking at 3 or more groups, like what is your trust in media, okay, by Republican, Democrat, Independent, 3 groups or more, we're in an overworld. Associations, nominal and nominal, male, female sex by diagnosis, yes, no, okay, we're in chi-square. So any kind of nominal and nominal, you can have more than 2 levels of those nominals, by the way. And these are very common tests, okay? If I'm looking for the association between 2 scale variables, income and savings, or any other 2 scale, endurance ratings and runtime, okay? Pearson correlation is the test of choice. There's also assumptions there. We can talk about that. Anytime we're predicting, and really the 2 main regressions are linear regression and logistic regression. The only difference is that the outcome variable in a linear regression is a scale variable, when in the binary logistic regression, it's in the word, binary, so you just have 2 outcomes, okay? Or the outcome has 2 levels, I should say. All right, it's logistic regression or binary logistic regression, okay? And we do have a built-in decision tree that can help guide you to that correct test, right? Okay, a moment about control charts. So control charts are basically looking to see if there's deviations outside of plus or minus 3 standard deviations. Basically, if we're looking at, I think this may be, well, hand hygiene, okay? But it could be anything, any kind of outcome variable. You're looking to see how the percentage of hand washing over time. But here you can see, hey gosh, in April, hand hygiene compliance was greater than 95%. You may have done some intervention at that time. So you want to see some kind of statistical deviation up or down, and it would highlight what's going on or ask you what's going on there, okay? So here you can see the dark line is the compliance, upper and lower limits, and then the average is 85%. And we have a whole slew of run charts, control charts, okay? That is very easy to use. One cool thing about our control charts or run charts is that often that there's different standards like JACO or other ones, and that the tool will actually interpret to see if those assumptions were met or not, okay? Whether those standards were met. Okay, setting up data, important that you'll notice I have on the left, the paired t-test, I have 3 nurses. their pre and post score is on the same row. Often they're stacked or in the different sheets or whatever. You need one sheet, okay, with each participant on one row, okay? You can have another column for demographics or things of that sort, okay? But one participant, both scores on one row. That's really important to set up for the analysis. For the independent sample t-test, we still have one participant on a row, but we're going to have a different group. So you may well be in an intervention group or treatment group or control group. Okay, so take a note of how those are set up. Same one participant, one row, but notice that the columns may well be different. Okay. Okay, so if I had knowledge scores from the same nurses before and after some intervention of an education, okay, what test would I be using? I'm looking for 100% here, but I'll take other answers. Okay, give other people a minute to check in here. Melissa, we are giving out prizes to 100%, correct?
Sure.
His and her Corvettes and a trip to Hawaii. Is that what we talked about?
That seems reasonable.
Perfect. Okay. All right. So if we're doing the same nurses pre to post, okay, and over 90% of you got it correct, good job. Same people pre to post, we'll go back. Pre to post, same people, we're doing a paired sample t-test, okay? An independent sample t-test would be happening. See, these are different nurses in different groups, okay? So that's when they would be independent groupings, okay? And just think paired, matched people pre to post versus independent, okay? Different groups. These people hand washing as usual. These people, they got some education about the importance of hand washing in front of the patient or something of that sort, okay? All right. So a quick conversation about statistical significance and clinical significance. Most of the world in these DMP scholarly projects or evidence-based practice is purely looking at statistical significance. And that's really important because statistical significance gives us the ability to generalize to a similar population, okay? And it's typically based on this 0.05, which means, hey, you know what? 95 times out of 100, we're going to find similar differences in a new sample. Okay. However, very often with DMP projects, the sample size is really small. I did a project with 3 participants. That's what they can get. During COVID, small participant pool. Okay. But so that's going to impact the ability to find statistical significance. However, clinical significance is also really important. And it's important because you may not meet statistical significance, but it's an important difference. For example, if you can reduce falls by 30% and it does not reach statistical significance, okay, but that's huge, right? Particularly for those participants. So you want to look not only at the probability, statistical significance, you want to look at the effect size. And in the paired t-test, that's indicated by a small d, which is Cohen's d. And anything north of 0.5 is a large effect size, indicating that it's meaningfully important, okay? So just heads up, and if you run the discussion chapter in Intellectus, it will talk about that, okay? Sometimes it can be statistically significant and not clinical. not statistical, but clinical, sometimes both, sometimes neither. So you got a few permutations of that. But I just want to highlight that clinical significance really makes is an important factor to put into it, particularly with small samples where statistical significance may not be evidenced. I think that's a type 2 error, right? Type 2. Type 1, you found something that didn't happen. So I think it's a type 2 error. You didn't find anything, but something really happened. Okay. So small samples kind of limit your ability to find statistical significance. In that example with 3 participants, they still found significance. Okay. So if you have a large enough differences pre to post, you can still find something. And to me personally, these things are just exercises in research. Whether you find significance or not, um, really doesn't matter. It matters perhaps for publication, but it doesn't matter when it comes to job prospects or whatever. In fact, in my master's degree, there was a potential prof coming in for a job, and she joked and said, all my colleagues found significance, but I didn't. And we all kind of laughed. And it's not only what you find, it's how you present what you find and who you are. That's what's going to make the difference in the job, okay? Rather than necessarily finding significance, particularly if you had a small sample size, okay? All right. This is just reiterating what I just said. You can have statistical but not clinical, clinical but not statistical, or both. Okay, and it's an important thing to consider. Okay, so and I kind of gave away the answer earlier, but we'll test it out. A fall prevention bundle cuts falls by 30% in a pilot, and the p-value is 0.07. Do you have statistically significant only, clinically significant only? Neither. And I guess I could have asked both, but we'll just go with ABC this time to see what we have here. I appreciate everyone weighing in here. All right, and we'll give another second here. Okay, so surveys are in here. So I don't think my question was totally great. We know that it is not statistically significant. Okay, that p needs to be 0.05 or less. Okay, so it is not statistically significant. That's for sure. So A is out. Okay, clinically significant only. I didn't really say what the criteria was for clinically significant, but as I mentioned earlier, if you're think about it, if you're reducing falls by 30%, okay, the attorneys at the hospital are going to be incredibly happy, okay, and the patients are going to be incredibly happy, okay. Think about reducing falls by 30%, okay, so it's likely clinically significant that you can reduce those falls, okay? So I'll give the neither people, the 4 people that said neither, the benefit because I didn't specify what clinically significant is. So neither could be, it was not statistically significant, and I didn't really define clinical significance. But just eyeballing it, 30% seems like a pretty fair reduction in falls. Okay, so those who say clinically significant, 60%, great job. Those that said neither, I'll give you credit there. Okay, but for me not defining what clinical is. Okay. But statistically significant, know that it's got to be 0.05 or less, though. That's the kind of the standard in science, okay? Um, by the way, that's not a God-given number. Some people I have seen, so I'll give a little bit of credit to statistical significance. Some people use a significant level of 0.10, not 0.05. So, but traditionally it's 0.05. Um, okay, so, all right. So a couple of things about the tool. As I mentioned earlier, the data cleaning is 90% of the job, if not more. And we have a nice data cleaning wizard, which does things like allows you to shorten the name of the variable. You don't want to put the whole question in there, okay? If you have 10 questions, don't put the questions in. Label them Q1 to Q10, all right? Or Q1 pre to Q10 pre, all right? It quickly allows you to make composite scores or sum scales. It gets rid of outliers, handles missing data, can reverse code items, okay? And it can transform variables as well into sums or composites, okay? Um, a quick moment about missing data. There's two types of missing data in the world. One is randomly missing data and one is systematically missing data. If you have a 10 question survey, okay, and you miss one item or two items, you can impute the mean from everybody else. And so you want to retain folks, okay, or participants. So typically, I think the benchmark, Melissa, you could double check me on this. I think if it's 20% or less, I'm pretty comfortable imputing a score there in that cell that's missing, so I can. But they've answered the other 8 or 9 of them. Okay, if you're missing 8 of them, that person's out of there. Okay, so know that you don't have to throw people out if you're just missing an item or two. Okay, or I would say 20%. But you could double check me on that. The tool also offers a discussion draft. This is the winner. So what it's doing is it's taking your particular results and put it in the context of the literature. That's a big deal, okay? So it's contextualizing your findings. It's also talking about the implications, not only for practice, but for theory. It also provides limitations and future research and conclusions. So go through that process for 5 minutes, okay? And you're going to have a draft of a discussion chapter that you can really add your own thoughts to, okay? Okay, so which part of the data analysis plan worries you the most? Choosing the correct test, okay? The right test, setting up your data or cleaning, or interpreting and writing up the results. Um, okay, about half the folks have answered this. Give it another minute here for other folks. Okay, about 25% choosing the right test, setting up data, just one folk, data setup, and then interpreting. Okay, so the good news is that selecting the right test, you can use the decision tree, but you can also so the decision tree is going to help you with that. Okay, setting up the data, we have mock data sets, and I'll show you those. And you can look at the particular pair t-test and look at how that mock data is set up. That's going to help you figure out how to set that data up. The data cleaning wizard will help you clean that data. Okay. And then interpreting and writing up, excuse me. So fortunately, Intellectus drafts those results in plain English prose, okay? Including assumptions, including APA tables. So, we got you there, okay? And now we're off to the demo. So you can log in here. Melissa, if you would put my email address in there. If you have data you're working on, happy to work through an example using your data, okay? So if you would log into this, or you could just watch along, follow along, that's fine too. All right, and I think we're going to go right to, we're going to go there. We'll get to questions and answers. Let me just pop that on the screen real quick. Ashley is here to support all the faculty on this call. All right. Again, for demos, for trials, we have 80 courses, okay, that go to different tests and research design and so forth. Melissa for students, any other general questions, okay? Institutional pricing, neither one of them can deal with that. Our phone number, our email address that talks about all of the tools, including qualitative, including lit review, and including methodologies, which will be out. Melissa could probably answer that best, but I'm assuming over the next month we'll have that. If you would like a free 20-minute consultation for students to kind of do a kind of evaluation and to get it is paid support, you can select that QR link or take a picture of it. Faculty, happy to help you with your project, okay? And let's just get to the tool. Okay, should I answer some questions first?
I don't have any waiting right now, but everyone's welcome to put them in the Q&A or the chat as you have them.
Okay, we got a woohoo, thank you for that. Will we have access to the slides? Yes, we'll have that. 30% is a lot. Yes, it is. Where did we get the D from? Arisha. So we get so when we conduct any of these tests, that D comes out is automatically calculated for you. Okay. So that's a good question. Okay. And if anyone wants to share their project, you can just rebooting. You can go to the share button. Okay, type in my email address, which Melissa will put in the chat or into the chat and share your project. Okay. All right. And then just type in my email, click share, and then I'll have it there. Okay, let's talk about decision trees, data setup, and interpretation. So the decision tree function is here under decision tree. And here you can, click around, you can't break it. I would like to predict an outcome and the outcome variable is scale. I'm doing a linear regression. So this is going to drive you to many of the analyses. It doesn't drive you to every analysis, but for a vast majority of folks, it will get you there. Once you know you're doing a particular test, say a pair t-test, if you click on the pair t-test, you can get a little write-up about what that data analysis plan looks like. You can download this, okay, and edit this. The other piece for the methodology, folks, is the power analysis, which is after I know what test I'm doing, like a pair t-test, it gives you different sample sizes based on effect sizes. Rule of thumb is you could use a medium effect size. I know most folks are going to have small samples, so the large effect it's really based on, this is based on two things. One is the theoretical effect size. So someone used the confidence interval before and they found a large effect size. I can use a large effect size and that sample size that's associated with it. The other piece of it is the practical part of it. So, hey, you know what? The literature says people have a small effect size between confidence, pre to post, or whatever, but there's no way in God's earth I'm going to get 199. So there's a practical piece of this, okay? So just know that those are two competing things when selecting sample sizes. If you happen to have access to a small sample, just check it out with your faculty member and say, hey, you know what, I can only get 12 people. Can I run with this? Okay. All right. So that's selecting tests. In terms of data setup, once you know that you're doing, let's just say a paired t-test, people are using that. Under the choose an example data set, you can look at these by test, okay? And if you go to paired t-test, so paired t-test, so exercise, once you select that, you can see, hey, I'm comparing time 1 to time 2. When you create that project, you can see time 1 and time 2 are in different columns, okay? So that's just a little clue to show you how to set up data, okay? Because one person asked about data setup. So go to projects, go to the example data sets, and then select the tests and see how that data is set up, okay? All right. Let's see if anybody has shared data. No takers yet. Okay, so let's go ahead and just look at some sample data here. I guess I should say something about uploading the data. You can upload data here. So it's under projects, under upload data. You can select the file format, okay, and then just select where your file's from, okay. You can also enter data manually or paste in like your Excel file in the right format, okay, but you can just paste in, a bunch of cells there in one shot to upload it manually, okay. So here's an example data set. Let's just do some basic things. So first thing we should do is with all data, you should always run descriptives first. And to run descriptives, you go to descriptives and select your variables. Let's just say I'm looking at gender and time 1 and time 2 and run time, maybe distance. Note too that these icons represent scale, level of measurement, nominal level, and ordinal level, okay? Also note that in each one of these dialog boxes, be it in management, plots, or analyses, there's always a 3-minute video tutorial there for you, okay? And also note that the options are already selected, but if you want to tweak those options, you're able to do that. So I'm running descriptives on those variables. So just add to the analyses. It pre-sorts, if you have a nominal or ordinal variable, it will, if I can double click there, it will make you an APA table and then give you a little write-up about that. Okay. For the scale variables, it will give you a little write-up and the table of that. If you don't know what these things indicate, you can scroll over and you can see what that acronym means, okay? And then let's just do a simple paired t-test. So I go into t-test of paired, and I want to see if there's differences in time 1 to time 2. Maybe there was some intervention of cardiovascular exercise in between, comparing time 1 to time 2. The video's there, the options are there, and hit calculate. So with each one of these tests, if there's an assumption, that assumption is going to be built in. It's also a reminder that in a paired t-test, there's an assumption of normality. That normality was assessed with that test called the Shapiro-Wilk test. The tool then runs the test, okay, with a result, and then interprets the test, okay? So for this particular data set, the normality assumption was violated. Just to keep note of that. We then have a draft write-up that says, hey, gosh, we found significant differences between pre and post. You can see that the runtime increased, okay? Maybe instead of the intervention of cardiovascular, maybe we had 5 cheeseburgers in between here because the runtime is longer. You can see that that p-value is less than 0.05, okay? And you can see that D, if you scroll over, that's our Cohen's D that I mentioned earlier, which is talking about the effect size. And then we have a little plot, which is showing both the means of runtime and then the error bars. Okay. Now, when a t-test assumption is violated, the Wilcoxon is looking at the same thing, time from pre to post, but it does not have those assumptions. Here we can see that it also was significant. P-value is less than 0.05. And here we're looking at medians rather than means. My rule of thumb is if we're doing something simple like a paired t-test, the assumption is violated, but that Wilcoxon is kind of doing a fidelity check that, hey, gosh, there's still differences pre to post. I would just run with the paired t-test, cite the violation of the normality, and just report it, because means are going to be much easier to talk about. Hey, gosh, they had an average runtime of 29 minutes at first and 30 minutes after, okay? And then then you can go to a discussion chapter and generate a discussion draft. And it's going to ask you, it should ask you. Let me try this one more time here. Otherwise, I'll reboot. Well, let me just go to an actual discussion draft. Show what that looks like. I have a data set here. I've conducted some analysis around Matchlock's burnout scale. I ran descriptives. I ran some correlations. And then I did a t-test to see if there were differences on emotional exhaustion by sex, which there was. Then I ran a discussion draft. And in that discussion draft, you'll have an introduction. You'll have a summary of findings, okay? Interpretation of those findings, theoretical and practical implications of those findings. And you'll notice that it's tapping into the literature here, okay? Limitations, okay? Recommendations and conclusions. For those faculty on the line, we also have a cool thing to check students' understanding of those findings. So if you click on reflections, you can go through and have the student fill out the accuracy and completeness, and it's going to walk through those different steps of that output. And then you can download that draft, which is going to have those reflection answers in there, okay? So the reflections is a cool thing there. Okay. All right. Questions here. Are there any questions for me?
I don't have any right now. Please feel free, anyone, to put them in the chat or raise your hand. And then just another tip about the reflections. It's really useful for students as well. You can fill it out and help guide, editing of that document. So for both
Yes.
students and faculty.
Yep. And for accreditors too, by the way, if there's any deans on the line that you have evidence of critical thinking here. So all three constituents, it seems like that's going to be useful for that. Okay, one new, okay. All right, anybody have any questions about their own particular analysis? Just raise your hand and I'm happy to talk for a minute. Is there any hand raising? Okay. Let me just state too that we do have Intellectus. So under the intellectus360.com, you can look at the lit review statistical tool I just showed and the qualitative. We'll update that with methodology when it gets here. Schedule a demo, and so forth. Okay, so that's all sitting here. I'll mention one other thing about the tools. I think I'm under here. Melissa, can I get to the tools can I get to the lessons here?
Yep, they're under either the statistics tool or qualitative tool,
Okay, so I go to statistics tool.
and then curriculum at the top.
Oh, thank you. Okay. So you have lots of tools to be had, and here are all the different lessons. Okay, so this correlation would have all of these in there and so forth. Okay. And I think they're $5 a lesson or something of that sort. Is that accurate?
If you purchase them individually.
Okay. Oftentimes when departments purchase the tool, it goes behind your single sign-on, and you can often just package those lessons for a nominal price. Okay. All right, final questions or thoughts? All right. Well, you'll all get the copy of this video. Please share this with friends and colleagues. And then we'll update you with upcoming webinars that we do every week, okay? So with that, I'll say thanks so much for attending to it. Thanks for answering the polls, and we'll see you all next time. Okay, thanks. Stay safe.